Okay guys, let's right. So the first topic is okay. First topic, redox. What are redox reactions? And reduction and oxidation takes place. Reduction is gain of electron, oxidation is loss of electrons. The one that gets reduced is oxidizing agent, the one that gets oxidized is reducing agent, right? But ये सब है, अपने को पूछते हैं ये सब नहीं पूछते हैं. They will ask you a balancing redox reaction and they will tell you कि मोल्स से कोई तो रिवर्स टाइट्रेशन का कैलकुलेशन करना है ना. Do you have any such question in mind कि सर ये रहा वो question? तो we'll solve that question. I believe redox में this question is the most important question है ना. But how to balance redox reaction? The basic steps are like this. Number one, find change in oxidation number है ना. Then so cross multiply, but cross multiply what? Reduction number to oxidized species है ना, and oxidation number to reduced species. फिर थर्ड क्या करेंगे?
If it is not cross multiplication, but you can find the simplest function.
बैलेंस चार्जेस सिंपलेस्ट नहीं आएगा ना. अगर बैलेंस कहाँ गया? बैलेंस चार्जेस नहीं है तो अभी तक सिंपलेस्ट नहीं आएगा तेरे पास. तो बैलेंस चार्जेस उसके लिए यूज H प्लस एंड H2O and electrons if required, not OH minus H plus. Generally MnO4 या Cr2O7, these are oxidizing agents, so they are in acidic medium, so you can take as many H plus as you want to balance the charges, right? Mali sahana koi? So if you put H plus on one side, add H2 on the other side. So because if I add H plus, I'll then have to balance hydrogen also. So है ना. So whichever side you add H plus, on the other side add H2O. है ना. Somehow you will find that the oxygen was also there in the equation all along, and this balancing also balanced oxygen. है ना. Question मिला भाई ऐसा किसी को? दोनों चलेगा. लाइए. ऑक्सीडेशन नंबर चेंज है. हाँ बिल्कुल કરી શકીએ છે. I think this does not have any change in oxidation number नहीं है, but we can use this. Let's say Mn2 plus BiO3, right, becomes MnO4 minus and plus. If I wanted to balance this equation, है ना, what were my steps? My steps were, I will look at what is the oxidation number change over here, है ना. What is the change? It goes from 2 plus to plus 7. Am I right? It goes from plus 6 to plus 3. So the change over here is 3. The change over here is 5. So you multiply 5 over here and you multiply. Are we sure the change is 3? Okay, so 3 over here. Then balance the charges. कैसे बैलेंस करेंगे चार्जेस? No beta, it does not balance the charge. See, 3 2s are 6 and here 3 1s are 3 and 5 3s are 15. 15 minus 5, 12. There are 12 positive charges more on this side. So you can add 12 hydrogen H plus over there. And if you add 12 H plus, 6 H2O over here. Should I think 5 3s are 15. 15 and 12 and 6.
How is it 12 charge for the charge? 5 and 15.
हाँ sorry. क्या क्या? हाँ इसीलिए तो मैंने पूछा कि ये श्योर 3 हो रहा है. स्टेप बाय स्टेप खुद के नोटबुक में भी कर सकते हो ना,
ये 5 और 3 है
पक्का।
पक्का है MnO4 to is plus 7 and
It's
plus
like
3 है that is तो 5 है
plus 6 होगा
plus
ना,
6
इसलिए
plus
हम
3 plus
counted the
6
charge.
तो 6 ही होगा
I want her to
Mn2 प्लस BiO3 है ना कि 2 है? श्योर। MnO4 माइनस एंड Bi3 प्लस 2 प्लस है, 3 प्लस है ना। Look at this. How you find out charge of Mn over here? X plus 4 times of minus 2 gives minus 1. You will find that X is plus 7. Then what is the change over here, beta? 5. Right? Then this is BiO3 or is it BiO2 or BiO4? So X minus 6 is 0. X has to be plus 6. This is 3. So you multiply it over here. What do we find? This is 3 is the change. So you multiply 3 over here and you multiply 5 over here. फिर अब क्या करेंगे? Now you find out the charges. 3 2s are 6, right? So plus 6 and nothing else. So plus 6 on this side. 3 1s are 3 and 5 3s are 15. So how many charges over here? How many charges are we deficient? 6. So I will write plus 6H plus, है ना? बैलेंस हो रहा है क्या? देखो मेरे हिसाब से हो गया। I don't think so. Because with H plus your oxygen is also in unbalanced.
If you just not again, oxygen is unbalanced.
No, it's not.
We have 3 into 4, 12, 10 and 12 plus 15. I said 5 into 3. So yeah,
It is balanced. Right? You don't even need to look at oxygen in this case. Right? And somehow in the textbook कुछ और ही equation है ना? Is it?
yeah, it's 2, 5 and 14 H plus.
Hmm.
And then 2, 5 and 7 H2.
It's okay. This is balanced, right? You are learning balancing. This is balanced. वो कुछ अलग context में they are asking about moles. छोड़ दो. Is this understandable? This is how you balance reaction. This is the only thing that is important in this chapter. One more important thing we will also look in chlorine is that NaCl reacts with Cl2 reacts with NaOH. NaOH concentrated and hot हो सकता है, cold and dilute हो सकता है ना? So NaOH plus 3Cl2 gives, let's say this is hot and concentrated, then what are the products? NaCl balancing क्या है?
3 1
6 and
3H2O
क्या बात करता है यार? डन? साम्या नंबर છે બેટા? આંખમાં નંબર આયા છે? નંબર આયા છે આંખમાં એમ પૂછું. સાચે પૂછું છું. ઓકે. ठीक है? So this is for hot and concentrated. What happens when it is cold and dilute? यहाँ पे 3Cl2 आएगा. NaClO plus okay
2 NaOH and 1 Cl2
okay 2 NaOH बोला है ना? What is this? This is also disproportionation reaction. Chlorine is getting both oxidized and reduced. Here the oxidation number is plus 7. Here it is minus 1. Here it is plus 1 and -1 है ना. Second thing that is important in this chapter, then oxidizing and reducing agent का general definition and a lot of use in mole वाले questions, right? Do you guys remember anything else that is important in this chapter? I don't.
General definition of disproportionation.
Disproportionation definition, that what is disproportionation, right? After redox, what do we have?
Enthalpy.
हो क्या था
ठीक है चलो. ओके. इक्विलिब्रियम. ओके. इक्विलिब्रियम में सबसे अच्छा, आई एम नॉट गोइंग टू एक्सप्लेन द टॉपिक इक्विलिब्रियम, वो लेफ्ट हैंड राइट हैंड सब कुछ उतना पता है ना. नाउ इक्विलिब्रियम कांस्टेंट्स, let's suppose this is an equation. Okay, you add 1 mole of nitrogen and 1 mole of hydrogen, right, to produce ammonia, right? Initially you have this much quantity. When equilibrium is reached, you have 0.25 mole of NH3 and they have asked you to find Kp and Kc. Okay, yes. So first write down the state symbols if already not given. Should be given generally, है ना. Kp can be found out using only gases, Kc can be found out for anything, है ना. So we will use initial, how much is changed and how much is present at equilibrium. For this to form 0.25, right? So can I write 0.25 added 0.25 mole, that is the change, है ना. What is happening over here, out of 1 mole, if this is 0.25 mole, how much of this will be used?
0.75.
Sure, the ratio is 2:3, so 0.25 divided by 2 and then multiplied by 3, right?
0.125.
Multiplied by 3, so it should be 0.375. So 0.375 moles of this are used up, so I will write a negative sign. And then nitrogen, how much ever of this forms, half nitrogen is used, so minus 0.125. So what is at equilibrium? Can I say at equilibrium this should be 0.875, right? ये कितना हो जाएगा? 625 and 0.2, 0.25.
I don't. एक second. I got the 0.5.
So I just subtracted how much ever change was from the total quantity that was available. No, I said in the starting of the question is like this, that you take 1 mole of each, equilibrium is established, at equilibrium you found the ammonia is 0.25 mole.
So you have subtracted the mole.
Yes, and therefore it will give me the moles at equilibrium.
If we had a question that they had given us, ki, no, actually start. Why did you half it?
Half because the ratio is 2:1.
How do we know the sign negative?
Because reactants decrease and products increase, right? All of this is taken care of now. Once you have this, then you can use your equation for Kp and Kc, right? So for Kc, right, I will require concentration. So concentration for this is 0.25 upon the total of this. What is the total? 0.875 plus 0.625 plus 0.25. क्या होता है इसका टोटल? I have no idea.
875 plus 65 is 1.5, 1.5 plus 0.5, 1.7.
Okay, so 1.75, right? Mole. 625 upon 1.75. This is 0.875 upon 1.75. So what will be your Kc? Kc will be 0.25 upon 1.75 raised to power 2 divided by 0.625 upon 1.75 raised to power 3.875 upon 1.75.
Kc में direct mole fraction भी करें, don't you need to do volume to multiply by concentration?
So considering all of this happened in 1 dm cube, then this is correct, right? If volume was given, let's say 100 centimeter cube, then instead of this I will just use the है ना, or rather let's keep it like this and let's say that this is kp, है ना, kp भी यही होगा, right? We have taken pressure.
Just directly do it, no? Not always.
Sorry.
For Kc, we can just directly use the formula for Kc.
Yes, we can, but what if volume was given 25 centimeter cube? Then you will have to find concentration. Here I have assumed, like I forgot to say, I have assumed that the question was framed like this, that 1 dm cube is the volume, right? So this is your kp. If somehow magically they have said that in equilibrium this is made to liquid, then you just use this logic to find out the number of moles of N2 and 3H2, but your Kp will be 1 upon whatever this value is.
So because it is the liquid in Kp, it becomes
You do not consider Kp,
in the equation only, right?
or rather actually because 0 moles on the product side, so the value of Kp is 0.
Yeah.
No product. Basically what will happen, the equilibrium will stay towards one side.
So if it wasn't 1 dm cube, then what we do for Kc? If you take it for Kp,
Let's say this is कितना volume चाहिए तेरे को बोल?
0.5.
0.5 what? cm cube?
0.5 dm.
Okay. Then you will find the concentration. The concentration is 0.875 upon 0.5, 0.625 upon
So
0.5.
If they ask for
Kc, then you find concentration. They ask for Kp, you can directly use mole fraction,
okay.
provided you are only using gases.
You can only use Kp if all are gases. It's not that you have to.
जैसे अगर ये liquid है तो this volume will not be 1.75, no, because this is liquid.
Yes.
So you will only use 1.5 आ जाएगा इधर.
So Kp, do we not need partial pressure?
Yes, partial pressure and molar like partial pressure and molar fraction are equal. Their ratios are equal.
So let's take the liquid one. N2 and H2, and we are taking away NH3 as a liquid. Then obviously we won't have any Kp because the NH3 is not in pressure. There is no pressure on the NH3. So what about Kc in that case?
Kc can be taken because Kc तो concentration है, liquid का भी concentration तो हो ही सकता है.
Liquid का concentration कैसे लेंगे? Take liquid का concentration compared to how much ever liquid you get in volume.
So because see, when we find concentration, even if it's liquid or solid, assume NaCl, that is solid. But how can we find concentration? Because it dissolves. So whenever it dissolves, no matter if it's liquid or solid, you can find concentration.
So there are N2 and 3H2 gas in there, and NH3 is liquid. So liquid concentration we know very easily.
But then we assume that all of these are in the same volume of liquid.
So we assume that the N2 and 3H2 are also in liquid.
नहीं, अरे वैसे नहीं, वाटर में डिसॉल्व है सब कुछ.
अच्छा, okay.
ऐसे करके.
Okay.
So there is a question on we don't consider partial pressure, but that's only if it's equimolar. Then either to affect that because that is raised to 2 and that is raised to 3. The pressure won't cancel out. Total pressure को multiply करना पड़ता है mole fraction.
Okay.
क्योंकि ऊपर तो for example मानो mole fraction 0.25 or 1.75 whatever है, raised to 2 है. But ये नीचे raised to 3 है. Into that तो answer अलग होगा as compared to if we take partial pressure.
हाँ.
है ना, क्योंकि पावर्स अलग है तो अफेक्ट नहीं कर सकते. अगर नीचे भी स्क्वायर और ऊपर भी स्क्वायर हो तो मुझे कैंसिल आउट हो जाता है.
हाँ.
पर स्क्वायर एंड
क्वेश्चन में नहीं आया लास्ट पेज में.
हाँ.
सेम क्वेश्चन.
यूनिट्स भी फाइंड करने का था.
हाँ.
है ना? right, let's say कि इसका equilibrium pressure 66 kilopascal है, then the partial pressure exerted by N2 is 0.875 upon 1.75, considering NH3 is a gas, multiplied by 66 kilopascal. That is the partial. समझ में आया कि partial you can take both, right? Let's say, देखो, let's take another equation, right? SO, some equations that we know. Let's take SO2 plus O2 gives 2SO3, and let's take H2 plus I2 gives 2HI, right? In this case, right, because there are 3 moles over here and 2 moles over here, right? What can you do is you have to consider, let's say they have said that 66 kilopascal or 200 pascal is the pressure, right? Then let's say कि इसका mole है x, right? इसका mole fraction x moles है. Multiply that by 200. This, because it's a mole fraction, it will be a number less than 1. So that is the pressure exerted by just this gas. You will accordingly find pressure exerted by each gas and then find Kp. But here if similar thing was given 200, you don't need to do that because moles on left hand side and moles on right hand side are equal. Yes, yes. Right? And in both these cases, you can also find out, can you use, should you use this method or not, by first finding the units. If it is a unitless number, the Kp, then you don't need to multiply it with the partial pressure thing, right? That is a proof कि दोनों side moles equal है या तो influence equal है, square, cube, whatever is happening, है ना? Yes.
And now over here, there is considered NH3 to be a liquid. And he said that there's another product which is being formed, but if that is a gas,
then you, yes, yes,
keep this one as zero.
yes, not zero, but you don't consider, you don't keep it in the equation basically.
You only keep the other product.
Yes, yes, yes. Huh? Okay, so that is equilibrium. Kp and Kc दोनों के units कैसे find करेंगे? Kp and Kc के unit, let's say Kc is equal to a raised to power b, और अभी हमारे पास जो था कि NH3 partial pressure raised to power 3, partial pressure of N2, partial pressure of H2, ये 2 था and this was 3, right? What you do is you find out कि total power क्या होगा. Let's consider this one. This is 2 minus 1 minus 3. The total power is minus 2. So simply, if it is partial pressure, then Pascal raised to power minus 2. If it was mole per dm cube, then that raised to power minus 2. Yes, this will give you dm raised to 6 upon mole square. है ना? That is the value of Kc, or that is the unit of Kc or Kp, है ना? इक्विलिब्रियम में इतना नहीं, इक्विलिब्रियम में इससे बहुत थोड़ा क्रेजी एक कॉन्सेप्ट है जो तुम लोग सब डर रहे हो, याद करो. Is this understandable? Do you remember anything except this from equilibrium?
Yeah.
What? Yes. Chem के बेटा, that was a change from 2022. हाँ, that was a part of AS level syllabus before this. In the same chapter, there is a chapter in A level, further aspects of equilibrium. That graph was in A level. Then in 2022, that was shifted to 22 or 21. It was shifted to AS level. Yes. So neutralization, right? According to me, those graphs are very easy. There are very few things that you have to consider, and you have to remember the rest of the graph. But let's go through what you have to consider and how do you understand it. Okay? The first thing is identify acids and base. है ना? Identify मतलब Is it weak or strong? Right? You will get an idea of your curve. This will give you idea of curve. Right? For example, if it is strong, तो curve कैसा आएगा? अच्छा, before I show that, the second is acid added to base or base added to acid. Right? Once you know these two things, you know your starting pH. Let's say a base is added to acid, है ना? तो acid का pH क्या होगा भाई? है ना? Let's say, so you start 0 to 14. This is your pH, and this is volume of base added. Right? As you go on adding the base, the pH changes. ये ग्राफ किसका है? Strong acid, strong base. What happens if base was not strong?
नीचे शार्प रहता है, ऊपर कम हो
जाएगा, ऐसे हो जाएगा, है ना? When it was strong and strong, the center of this would have been pH of 7. But here it will not be 7, it will be below 7. है ना? समझ में आ रहा है ना सबको? Okay. If it is a strong base but weak acid, sorry, है ना, something like this, because they have acid, what is added to what, है ना? So here the change in pH is greater than 7. This is, है ना, ये greater than 7 हो गया है ना भाई? बहुत नींद है. ओके, समथिंग लाइक दिस, है ना? ये स्ट्रॉन्ग बेस है, ये स्ट्रॉन्ग एसिड से स्टार्ट कर रहा था. अगर दोनों वीक है तो क्या करेगा भाई? है ना? अब ये चारों में मैजिक क्या है? ये चारों में मैजिक है दैट all of them use different indicators, because the sharpest change is at different pH. There are different indicators used, but ये याद रखना पड़ेगा. टेक्स्ट बुक में there is a list of 7 or 8 indicators, I think, है ना? टेबल है किधर? तो कौन सा टेबल है प्रभु? 8.11, पेज नंबर 198. Because what will happen is that is a very like logically मैं भी पहले ये यूज कर देता, बट दो चार एक्सपेरिमेंट करने के बाद क्या पता चलेगा कि pH 7 पे क्या कलर है यूनिवर्सल का? ग्रीन है. 8 पे ब्लू. तो तेरे पास शार्प चेंज ही नहीं है. ग्रीन से सबसे पहले तो देख, जब ग्रीन से ब्लू जाएगा तो क्या होगा? धीरे 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 चेंज होगा ना. तो तेरे पास पहले तो ग्रीन और ब्लू का एक मिक्सचर कलर बनेगा, है ना? तेरे को एग्जैक्ट एंड पॉइंट ही नहीं मिलेगा अगर तू यूनिवर्सल इंडिकेटर यूज करता है. यूनिवर्सल इंडिकेटर चेंज ऑब्जर्व करने के लिए नहीं है, यूनिवर्सल इंडिकेटर पीएच जानने के लिए. You cannot use pH like universal indicator as a indicator when there is a change in pH. You can only use it to find that pH. If you want to observe a sharp change, you have to use an indicator that has a single color, phenolphthalein, pink and colorless. So you know exact endpoint, right? They will ask this probably in your paper 3. Yes. Or why are we using this indicator? To observe sharp change. Yes. No. See, what you can start with is basically they will tell you. Most of the times they will tell you what should be the indicator, right? But then if it is strong acid, strong base, then the color change that you want to look at should be at pH 7. So you will use bromothymol, right? उसका sharp pH change क्यों पता होना चाहिए? Because that should be the almost vertical line that you draw in your graph, right? The center of that line. For example, you are using bromothymol, right? Bromothymol में कैसे बनाना पड़ेगा? You would have a graph 1, 2, 3, 4, 5, 6, whatever, right? And then you use bromothymol. This line should occur in such a way that the center is at 7. To know that, you must first know what is your indicator and what are your acids and base. Right? So, 2 point मैंने बताया. There is third point to this graph. Third point is finding out equation and mole ratio. Bro, सुनना है. Let's say I have added H2SO4 in NaOH. This will give you Na2SO4 and H2O. Right? This will be 2 moles. If I am using 1 mole per dm cube of both of them, है ना? And what am I doing? I am adding base to acid. Let's say I have started with 10 centimeter cube of acid. How much base will be required? 20. So this center should be a 20 centimeter cube.
And the middle of the change will be at 7.
हाँ, तो तुम लोगों को दोनों पॉइंट मिल गए. एक और चीज ध्यान रखनी है. Let's say it was HCl and NaOH gives NaCl and H2. इसमें दोनों सेम वॉल्यूम पे. So if I had taken 25 centimeter cube of this, you will also require. So that you can only know from the given conditions, है ना? If nothing is given, considering कि सब कुछ same है, ऐसा ही assumption लेके जाना पड़ेगा. तो you answer it like that. Make sense? जागी सकी इसमें? Okay. So that is equilibrium. What is the next topic? Huh? Yeah. After rate of reaction, we will take doubts. We have a lot of time, Adya. Okay. Rates of reaction. एकदम simple chapter है. They have only given you, like you already know that increasing the surface area increases the rate of reaction. You also know catalyst increases the rate of reaction. Concentration increases the temperature increases the rate of reaction. बाकी pressure में है ना. अब बाकी सब जगह except pressure and temperature, the thing is that उतना ही particle है, but there are more avenues for pollution, है ना? When you increase the amount, when you increase the surface area, and when you increase the concentration, there are more particles to react, so the reaction will increase. But in case of temperature, what happens is, if you look at energy distribution of particles, right? If I start making bar graph, कि zero energy and zero number of particles. Let's say this is energy and this is number of particles, है ना? If I start making a bar graph, what I'll find? Zero particles have zero energy, right? Very few particles have nearly zero energy. Some more particles have more than that energy, right? Bar graph बनते जाएंगे. If I join the center of this histogram बोलते हैं इसको कुछ ऐसे, touching bar graph को, है ना? So you make a histogram, you will find that this is the energy distribution between the particles. Something like this, where this is the activation energy. So in case of your reaction, only these many particles will react, right? This is at temperature T. Let's say I increase the temperature and take it to, ये temperature T1 था, ये T2 है. What will happen? So now इतने particles के पास इतनी energy थी. Now you increase the temperature, तो थोड़े और particles के पास ये energy redistribute हो जाएगी. Actually what has happened? These many particles now have extra energy. They have energy greater than the energy that was required to react. Therefore the rate of reaction will increase. What is this? This is Boltzmann distribution of energy, है ना? Boltzmann's curve.
Can you explain why the peak is lower in the
See, because let's say this was 1, 2, energy गिन लो कि 1, 2, 3, 4, 5, 6, 7, right? Sorry, energy like this. Let's say this is 100 joules, right? This center means that 500 particles, let's say, had energy 100 joules, right? But now what happens is, when you increase the temperature, every particle's kinetic energy increases. In turn, its temperature is also increasing. What will happen? Because the temperature is also increasing, that distribution will get broader. Now more particles will have, the particles that had very less energy, right? You think about these particles. These particles had very less energy. Now instead of particles that already had energy, them gaining energy, ये probability कम है. Particles that did not have that much energy will gain energy, and they will gain so much energy कि ये पूरा यहाँ पे आ जाएगा. This is how the curve changes a little bit downwards and rightwards. Right? This actually means that the distribution gets broader. पहले क्या था? Very less particles had a lot of energy. Very less particles had a lot of energy. Right? A lot of particles had lower amount of some energy. है ना? तो ये change हो गया पूरा distribution. Makes sense? है ना? Spread हो गया. Right? This is what it is. What does a catalyst do? It decreases the energy. Let's see. What if temperature T1 T2 नहीं किया हमने, at this point if you add a catalyst, the catalyst will then decrease the activation energy. So now these many particles have energy to react. So in both the cases the number of particles with enough energy to react increases, which increases the, if you just add a catalyst, now at temperature T2, yes, at temperature T2, if there was a catalyst, then obviously these are also the particles that will react. So doing both increases the rate of reaction twofold. है ना? Both of them cumulatively act to increase the rate of reaction even more. अब बोलो